Here is a parametric problem. They're giving you the velocity vector, which is dx dt and dy dt. Find all values of t at which the line tangent to the path of particle is vertical. So they're telling you that the tangent line is vertical. So we know in parametric form dy dx is dy dt over dx dt. A vertical tangent line means that the slope is undefined. The only way that the slope is undefined is if the bottom is 0, so you're looking for where dx dt equals 0. They give you dx dt, so all you're going to do is type this into your calculator, y1, y2, find the intersections, and they tell you they only want to look at your t value from 0 to 1.5. There are two places where this occurs. 1.2533. Okay, so you want to show them either this or this. That's your setup, and then use your calculator. Part B, write an equation for the tangent line. Okay, you should be thinking I need a slope, I need a point. Here's my slope, dy dt over dx dt. They want to know what happens when t equals 1. They give you both of these equations, typed it into your calculator, plug in t equals 1. I get a slope of 0.86344. Now, they want to know what happens when t equals 1. The only thing I'm missing is I need an x and a y value at that particular time. So you should be thinking in order to get the x coordinate and the y coordinate, I am going to need to integrate these. So I will integrate dx dt with respect to t, and that will give me the position. I want to use 1 as one of my bounds because that's what I'm looking for. And the only other point they give you information about is that t equals 0. So I'm going to integrate this using the bounds 0 and 1. This will give me x of 1 minus x of 0. X of 1 is what I'm looking for. This is given is -2. This, use your calculator to punch it out. Integrate dx dt from 0 to 1. And then go ahead and move this point over, so I end up with x of 1 equals 9.31469. You're going to do the same thing with dy dt. Or again, remember we talked about, to find the final value of something, we need to find the initial condition, add the net change, and that will give me that final value of y1. So same idea, I get y of 1 equals 4.6205. So then using all that, my equation is there we go. Okay, and part C, speed of the particle. Speed is just square root of dx dt squared plus dy dt squared. You're given both dx dt and dy dt. Plug in 1, just punch this out in your calculator, 4.10525. And part D, find the acceleration vector. Acceleration is just the derivative of these. Type these into your calculator. Have the calculator calculate the derivative, so you don't need to necessarily show them any work. So you should have the x component of the acceleration and the y component, all with the calculator.